Here we have a related rates example where we have two people walking. So a man starts walking north at 4 feet per second from a point P. I'm going to put point P here, and the man is walking north, so I'm going to draw a line going up. And I don't have a constant to mark that line because the placement of the man is going to change as he walks. So I'm just going to call it M, because I don't know where he is in relation to point P, but I know how fast he's moving with respect to time. dm dt is 4 feet per second. 5 minutes later, a woman starts walking south at 5 feet per second from a point 500 feet due east of P. So we're going to go east of P by 500 feet, and the woman is going to start walking 500 feet east. She's headed south. So where she is not a constant, so we'll call it W, but we know how fast she's moving since her position is changing, dw dt, we're going to note it with that 5 feet per second. And so we want to see at what rate are the people moving apart 15 minutes after the woman starts walking. So we want to figure out the rate, the distance between them is changing. We're trying to figure out this distance here. We can call it any letter we want. I might just call it Z. How fast is the distance between them changing? And this gives us kind of a big triangle. So here's our hypotenuse of the triangle, that distance between them, Z. We have the side of the triangle, which is made up of how far up the man has traveled, how far north he's gone, and how far south the woman has gone. So this whole side here is going to be measured by taking M plus W. That's going to tell the vertical distance between the two people. And then we have the base of our triangle here, which we know we started at point P for the man, and the woman was 500 feet due east. So this is actually a nice constant horizontal distance between them. We don't have to put a variable there. They're 500 feet apart. One's going up and one's going down. One's going north, the other's going south. So the equation that can relate the two would be the Pythagorean theorem. We have our base, which is going to be 500 feet getting squared, plus the height of the triangle, which is M plus W squared, equals our hypotenuse, that distance between them, which we could call it D or Z. You can give it any letter that you want. So we're going to have to use that equation and its derivative to solve this problem. So taking this derivative, the derivative of 500 squared is nice. It's 0 because it's a constant. Here we're going to use the chain rule. Our outer function, we have a u squared. So our derivative is going to be 2u. So 2 times m plus w. And then we're going to multiply that by the derivative of the inside, which derivative of m is just 1 dm dt. Plus the derivative of 1w is 1 dw dt, equals derivative of z squared is 2z dz dt. So that's what we're going to be plugging into to solve this problem. Before we can plug in, we need to figure out what we know and what we're solving for. So we have our three variables, m, w, and z, and their corresponding derivatives, their rates of change, how fast the man is walking, how fast the woman is walking, and then what we're trying to solve for, how fast is the distance between them changing 15 minutes after the woman started walking. So we're going to solve for z dt, but we're going to figure out what each of these variables is at first. So starting off, we're looking 15 minutes after the woman started walking. So let's figure out how far she is to start. So she's been walking for 15 minutes, and she's been walking at a rate of 5 feet per second. Looking at this W information here, we're trying to fill out this big triangle. and we know that she's been walking for 15 minutes for 5 feet per second. And so we can't just multiply those straight across because we have minutes and seconds in here. So I'm going to get this 60 seconds per minute in here. That way the seconds can cancel, the minutes can cancel, we'll be left with how many feet she's gone. So 15 minutes, going 5 feet per second, and there's 60 seconds in 1 minute. She's gone 4,500 feet south from where she started at 15 minutes later. Now let's figure out where the man is. So he's been walking for 5 minutes longer than the woman has. 5 minutes later, the woman left. So he's actually been walking for 20 minutes. So we're going to take 20 minutes since the woman left 5 minutes after him. And the rate that he's walking is 4 feet per second. And there are 60 seconds in a minute. Just so all these units cancel and we're left with how many feet he's gone. So 2 times 4 times 60, he's gone 4,800 feet north of point P. He's been walking for 20 minutes. He's made it 4,800 feet. The woman who is walking a little bit faster at 5 feet per second has only been walking for 15 minutes, but she's gone 4,500 feet. So let's see if we can figure out this other variable here. We're going to plug in to the Pythagorean theorem to figure out what z would have to be. So if we go to find z, z is going to be whatever 500 squared. We have m plus w getting squared. I'm plugging into this Pythagorean theorem here to figure out what z is, so that we can plug it into the equation. So we have 500 squared plus m plus w is getting squared. So 4,800 plus 4,500 is getting squared equals z squared. So we're getting a pretty big number here. When we plug in 500 squared, and then we have the quantity 4,800 plus 4,500 getting squared, z is going to end up being the square root of this 86,740,000. So a very big distance z. I'm not going to find the decimal value for it. I want to use exact values until my final answer. So there's that missing variable using the original equation. So, if you're missing an original variable, plug into the original equation. If you're missing a derivative, that's what you're solving for. You're given a derivative and asked for another derivative. Or in this case, we were given 2 derivatives. We know how fast the man is going is 4 feet per second. The woman is going 5 feet per second. And we're going to figure out how the distance between them is changing. And that's going to also be in feet per second. So let's go into that derivative, and now we can plug in everything except for dz dt, what we're solving for. So let's plug into this for all of the pieces that we know. So first piece we know is we have 2 times m plus w. 2 times 4,800 plus 4,500. That's getting multiplied with 1 dm dt, dm dt is just 4, plus 1 times dwt, which is dwd, dt is just 5, equals 2 times z is that crazy root of 86,740,000 times dz dt. So to get dz dt by itself, we're just going to divide by this quantity that it's multiplied with. Division will get rid of that multiplication, and then we can just plug this big fraction into our calculator. So we want to do that 2 times the quantity 4,800 plus 4,500 times the quantity 4 plus 5. That numerator is going to give us 167,400 divided by this 2 times the radical. We want to get what dz dt is, and it is approximately, to 2 decimal places, 8.99 feet per second. So as one is walking at 4 feet per second, the other is going away at 5 feet per second, the distance between the two 15 minutes later is changing by almost 9 feet per second. So a tough application of how we can use the Pythagorean theorem to solve related rates.